classifying segments inside triangles. So again, it says classify the segment in each part below. Only use the information given in the figure. Do not assume measures are equal unless the markings indicate they are. So basically it's saying don't trust the picture, only use the markings and what they actually give us. So even if the figure looks like it's congruent or the angles look like they're the same size, we can't use that as fact. We can only use facts as the facts that they gave us. So this says, if necessary, you may learn what the markings on a figure indicate. So if you click on this, it actually will go through and show you. So these slashes, which I call tick marks, mean side congruence. So one tick mark to one tick mark, that means the side AB is congruent to side CD, sorry, or DC. And then two tick marks to two tick marks mean that the top here, BC, is congruent to the bottom, AD. So we can match those. Arcs, that's how they show that angles are congruent. So again, one arc to one arc means that those are congruent. So I have angle A to angle D, and then B to C because two arc to two arcs. So we just match up the number. So yeah, whether it's, and they call it slashes, I always call them tick marks in my videos, but tick marks. And if you have more than four sides, you could have three tick marks to three tick marks, 4 to 4. So you can keep going like that. Same thing with arcs. So you just match up the number of arcs, and as long as it's the same number for each one, they are congruent. Arrows, so arrows actually show us that something is parallel. So we have one arrow to one arrow. That means that AB is parallel to BCD. And then two arrows to two arrows. So BC is parallel to AD. And then the last one they have in here is just the square. So this one shows us that it is a 90-degree angle. So whenever we see this, we know that it's 90 or right. It means the same thing because they're saying right angle in the words here. But a right angle is 90 degrees. All right, so that's just kind of a quick reference on markings. And again, I was able to click on that because it's blue and it's underlined. You can always click on those. So I can actually click on all of these also. I don't know if when we click start that these will also be blue and underlined. They might be. If they're not, they'll be over here in the dictionary. So all of these pieces are here. But sometimes the dictionary doesn't give it to you kind of as nicely as the explanation page. So sometimes the explanation page just gives it to you a little bit cleaner. The dictionary will give you the full definition. So if we scroll down, we have a perpendicular bisector of a segment is perpendicular. Perpendicular means that, in here, I'm going to click on my pen here so that I can write it. Perpendicular means that if I come down and I'm going to come down straight and I'm using this gray line here, so I'll just draw on here. So this is perpendicular because I'm going to put a 90. So even though I didn't measure it, I don't know 100%, that is a 90-degree angle, but I'm marking it that way. So again, we're using markings. We're not using our eye as far as deciding. So if I tell you that's 90 degrees for the problem, it's 90 degrees. The only time that you question that is if they say, measure it and tell me what the angle is. So perpendicular means that it's perpendicular, and bisector means that it cuts it in half. So let's say I have a point here, and I'm going to try to eyeball this a little bit here. So if it's a perpendicular bisector, not only is it perpendicular, but bisector means it cuts this line between the two dots in half. So this part would be equal to this part, from the dot to the line, from the dot to the line, because it's bisecting it. Bisect means to cut in half. Or it means that it's going right through the midpoint, as they say here. So this is the perpendicular bisector. If you are not writing notes, you should be writing notes. You should definitely write all of this down before clicking start and going to the next page. At least know what these things are, because you're going to have to identify all of these things in the diagram here. So you need to be able to know what they are. If you just click start without reading through the definitions, of course you don't know what to do on the next page. So make sure you slow down, write down some notes on what these things are, and then move to the next page. All right, so an angle bisector, so same thing, we hear bisector again. So here's an angle like this. So I have two rays. Remember, that's all an angle is. A ray is just an endpoint with a line going on forever in one direction. So we have two rays. A bisector means that it's going to have another ray and it's going to cut it in half like this. So I have one arc to one arc. Remember, we just went through the markings. One arc to one arc means that they are congruent. So that's all an angle bisector does, is it cuts an angle in half. Just like a perpendicular bisector cuts a line in half, angle bisector cuts an angle in half. All right, a median of a triangle is a segment that connects a vertex to the midpoint of the side opposite that vertex. So if I have a triangle, I'm going to just draw a triangle here. Here's a vertex, and if I want to draw a median, I have to go down, so not straight down. I have to go down, because if I go straight down like this, that's actually, we could call that a perpendicular bisector, but it doesn't look like it cuts it in half. So this is a perpendicular, sorry, not bisector, just a perpendicular line, which we call an altitude. So this is actually an altitude, which is the next one. So we have to be careful mixing these up. And I just mixed them up when I said that. That was silly. So I'm going to start at this vertex, and I'm going to draw a median. So this looks like about the midpoint right here. So I'm going to draw this line going over. So it can actually go diagonally. It doesn't have to go straight down. It just goes from the vertex to the midpoint. Remember, the midpoint means that these two lines are the same. So from this vertex to the line, the median, and from this vertex to the median, those would be the same, because I just drew this line to the midpoint. Midpoint means it's halfway between. So that would mean that these two lines are the same. All right, and let's go back to altitude real quick. So it says the altitude of a triangle is a segment that connects a vertex to the opposite side that vertex. So we have to go from the vertex to the opposite side, and it's perpendicular to that opposite side. So it can bisect it. That does happen sometimes, where you have a line that is going from the vertex straight down, it's perpendicular, and it bisects it. So that can happen, but perpendicular bisectors don't always have to go through the vertex. So it can happen that way, but it's not a guarantee that a perpendicular bisector will actually go through the vertex. So we actually see this example right here in C. So I'm going to use this one as an example. This is a perpendicular bisector. It's not going through the vertex here. It's actually just kind of coming through a random point in the side here. But it's perpendicular to this side, and it bisects it. So we call it a perpendicular bisector. If we were to draw a line from here to here, this is now the median, because it's going from this vertex here to the midpoint. And again, the bisector meant that it was in the midpoint, because I know that's a perpendicular bisector. So the perpendicular bisector doesn't have to go through the vertex. It can, it does happen, but it's not a requirement. All right, so now that we've gone over all of these fun definitions here, we have enough so that we can go through. And again, you should be writing down the definition and at least drawing some kind of example next to it, so you remember what does that actually look like. Because when you get to the next screen, all of the definitions are gone. So we're going to clear, and we're going to go to the next screen. Whoops, I got to click my cursor here. If I haven't said it already, this tool that I'm using to draw right on the screen is called PageMarker. It's a Google Chrome extension. It's pretty cool. You just download it from Google Chrome after you look up PageMarker on Google Chrome, and here it is. It's just a little pencil tool that I click on and off, and it's pretty neat. Anyway, I just like my little extension, so I'm telling you about it. Okay, so they did give us the blue lines. So they gave us all of these definitions still. So I can click on this, and it'll still tell me what a perpendicular bisector is. So if you didn't write your definitions down, luckily they're giving them to you. They don't always do this. So definitely write down some notes. All right, so let's go through and look at what we have. So we're going to classify each segment here, and they tell us which segment we're looking for. So I'm going to switch over here to my pencil. So we're looking for ZV, sorry. So ZV is this line going through the triangle here. So we want to classify, whoops, I got to click over to my cursor here. I keep forgetting that. So we have to classify this line here. So it's not perpendicular. I can see that. There is no square mark. So I'm not going to click perpendicular. Angle bisector. Nothing about the angles is shown. It would actually have to show me those arcs so that I know that this is talking about angles. So I'm not going to click angle. Median. So this line goes from the vertex and it goes right to the midpoint here. I know it's the midpoint because I have a tick mark and I have a tick mark. So YV is congruent to XV. So I can see that. So that means that this point right here must be a midpoint. And that's the definition of median, to go from the vertex to the midpoint. So I will click median. Altitude requires a 90-degree angle. So I'm not going to click altitude. All right, next one. Select all that apply for ST. So we have this line here now. And we actually already looked at this on the last page for our example. So it is perpendicular. So I know that I can select one of the perpendiculars. And it's also a midpoint. I can see that because, again, these tick marks tell me it is in the middle. So it's perpendicular and it's bisecting. I know it's bisecting because it's in the middle, and that's what bisect means, to cut it through the middle or cut it in half. So it's a perpendicular bisector. I don't think they'll ever be tricky about this, but make sure it says QR, so you're actually bisecting the correct side. Because if it said ST is a perpendicular bisector of PQ, well, no, it's not. So I don't think they'd ever trick you like that, but just make sure you're paying attention. It doesn't give us any angle marks, so we're not going to do this one. Median, it is in the middle, but the other part of the definition of median is that it has to come from the vertex. So it would have to come from P to that point. So we don't have median. Altitude also has to come from, oh, you know what? Am I lying? Does that have to come from the vertex? I'm going to click on it real quick just to make sure. Altitude is a triangle that extends from a vertex. So it does have to extend from a vertex. I wanted to make sure on my definition there. Because since I didn't have them written down from the last page, the only thing with this tool is it doesn't allow me to nicely bring notes from one page to the other. So we want to make sure that it goes through the vertex. It would have to go through P, go straight down, and then that's an altitude. So it wouldn't actually land in that same spot because we don't need it to be at the median. We just need it to be at a 90-degree angle. So if I tried it, let's see, it would go straight down, something along those lines like that. That would be an altitude. Okay. All right. Last one here. Select all that describe HI here. So we're describing high. So it is perpendicular, but I'm not being shown that it's bisecting anything. So we're not going to select perpendicular bisector. No angle marks are shown, so I'm not going to select angle bisector. Median. So it is going from the vertex and it's going straight down here, but I'm not being shown that it's in the middle. It looks like it's in the middle, but don't trust what it looks like. It has to tell you with the congruent marks. So I'm not going to select median. Altitude, it's going from the vertex straight down, and it has a 90-degree, so it's perpendicular to this opposite side. That is the definition of altitude. So let's click check, and we get our point. Okay, so I don't know how much we're going to go through each little piece in the next one. I'm just going to go through and see what I have. So KM, I can see it's going through the vertex, and it's perpendicular, so we call that an altitude. This one, oh, we're finally seeing these angle marks. So I can see one arc to one arc. That means they're congruent. So that means that this line here, DC, or CD, what they're asking us to do, is cutting that angle in half. To cut something in half, remember that word is bisector, and since we're talking about angle, it is an angle bisector. Let's see. So this one we have it going from the vertex to the midpoint. I know it's the midpoint because of the tick marks. So I have half and I have another half. Again, I know they're half. It's not telling me specifically they're half, but if they're the same thing on both sides, then it means it was cut into two equal pieces or it was cut in half. So it's just one of those relating the words there. All right, so I have the median because it goes from the vertex to the midpoint. Check. Yay. All right, one more. Okay. Oh, look, we have some more angle marks here. So I know half and half because, and what I mean by half is it's half of this whole angle here. So I have arc to arc, they're equal to the same thing. So this line must be cutting it in half or bisecting it. So angle bisector. All right, so I have a line that's not going through the vertex. So I know it's not going to be median or altitude. I can ignore those already. I also don't see any angle marks. So we're going to ignore angle bisector. So I do see, though, that it's perpendicular. And I see these little tick marks showing me that I have two equal sides, which means it's in the middle, which means that it was bisected. So it's perpendicular and bisecting, perpendicular, bisecting. All right, so last one here, we have a vertex going straight down to the middle. Again, I know it's the middle because I have two equal pieces here. So it means that this whole line, BC, was cut in half or bisected if we were using bisector. So we want median in this case because it's going from the vertex to the middle. I wouldn't use perpendicular bisector because it's not perpendicular. There's no angle marks, and it's not an altitude. Again, altitude requires it to be perpendicular. It does look perpendicular, but the mark isn't there, so I'm not going to click it. Alrighty, we're all done with that one. Yay!